Since 1915, physics has modeled reality as a four-dimensional block universe. Under general relativity, the past, present, and future are assumed to coexist as a single, static geometric structure. The architect of this geometry was Hermann Minkowski. His metric treats time as a fundamental traversable dimension, a mathematical move that fuses the observer's internal tracking mechanism with physical space. Elastic Continuum Theory, or ECT, offers a strictly three-dimensional alternative. This framework defines the universe as a continuous, hyperelastic solid, the plenum. In this model, the universe exists in a perpetual, absolute now. The medium functions as a purely 3D space, where the physical past has no structural representation in the lattice. If time has no independent physical reality, it must be accounted for elsewhere. ECT proposes that what we perceive as time is a specialized cognitive algorithm, a biological tool, evolved to measure physical displacements. To test this, we have to mathematically decouple the state tracking parameter, t, from spatial geometry and treat it strictly as a sequence of mechanical updates. Within a medium that solely contains its current topological strain, the arrow of time is reduced to localized thermodynamic damping. In a universe that only possesses the present state, the concept of time travel ceases to be a geometric problem. Without a temporal axis, the dynamics of the universe rely on the displacement field, u sub mu of x, y, z. This field defines how every point shifts and reacts to local stress. This equation represents the fundamental mechanics of the elastic continuum, calculating mechanical strain without a 4D spacetime metric. The parameter t appears here not as a dimensional axis, but as a scalar sequence index. It marks the order of updates in the lattice, similar to the frame count in a film. The physical state of the system is held in the Cauchy stress tensor. This value represents the current topological strain, which updates iteratively as the displacement field shifts. As it shifts, each state replaces the one before it. The medium retains no structural memory of previous geometric configurations. The only values that persist between these updates are the instantaneous momentum vectors. These vectors dictate the next shift in the lattice, but they do not preserve the past. The universe is governed by this localized topological strain, operated entirely through current mechanical states rather than historical coordinates. If the physical medium only exists in the now, the persistent observation of a continuous temporal flow requires a biological explanation. A biological organism functions as a highly complex, coupled solitonic subsystem, a stable wave pattern embedded within the plenum. To survive within a dynamic lattice, this subsystem must predict the motion of surrounding solitons, such as objects or predators, before they arrive. The central nervous system achieves this by continuously comparing the present state of the lattice with immediately preceding states stored in biological memory. This formulation defines perceived cognitive time, delta t cog. The brain integrates the shift between state 1 and state 2 across the sensory domain. The function f-neuro represents the neurological integration of sequential phase shifts, a process carried out by the hippocampus and prefrontal cortex. By mapping these discrete mechanical updates, the brain generates the cinematic illusion of temporal flow. The timeline of the universe is an endogenous construct. It is an artificial map created by the observer to navigate displacements of a 3D space. Redefining time as a cognitive construct allows for a mechanical reevaluation of Einstein's geometric model. In Einstein's metric, a negative square coordinate was assigned to the observer's cognitive tracking mechanism, effectively fusing a biological phenomenon with physical space. This math creates a false geometric dimension out of a sequence index. This geometric interpretation is often defended by the observed behavior of atomic clocks, which appear to experience time dilation when moved at high speeds. Under the ECT framework, an atomic clock is viewed strictly as a topological soliton, a physical oscillation within the 3D lattice. When this soliton pushes through the medium at extreme velocities, the lattice undergoes intense elastic strain, causing mechanical hysteresis. The resistance of the medium acts directly on the accelerating object. The clock's internal oscillations slow down. This localized frequency drop is a physical consequence of solitonic drag, not a change in a temporal dimension. The clock simply required more cognitive intervals, or delta t cog, to complete a single physical cycle. What has been interpreted as time dilation is a mechanical frequency shift, explainable through deterministic forces in three-dimensional space. This mechanical model scales from the behavior of individual clocks to the nature of the entire 3D solid vacuum. Time perception is analogous to color. On the left, an eye translates electromagnetic waves into a spectrum. On the right, a brain translates mechanical shifts into a timeline. Color doesn't exist objectively within waves, nor time within physical displacements. Both are sensory translations. Time is not a fabric to be warped by mass, nor a dimension to be traversed by matter. These findings necessitate a shift in how theoretical physics models the universe. Cosmology must look past the biological illusion of temporal geometry to understand the medium itself. By decoupling the observer from the geometry, physics returns to the deterministic, timeless reality of the elastic continuum.